Okay. So two-dimensional vectors mean that a vector quantity, like velocity displacement, has both x and y components. So, for example though, we look at just the overall net of what has happened. So, say I start here. Start. And say this is a ping pong ball or something, and it goes down a little bit, and then it goes up, and then it goes over, and then it goes back, and then it goes over again, and then it goes up. Okay? And that's where I finish. So I'm going to put a dot here and go finish. Well, now, that's ridiculous. To figure out this problem using those vectors is silly. So I'm going to just draw a line going from my start to my finish to make it a lot simpler. So, start to finish. But, say I'm using northeast, southwest. This vector, this red vector that I've drawn, is neither north nor east. It is northeast, right? So I need to understand how far north it's gone. That's my vertical component. And how far east it's gone. My horizontal component. So I need to figure out, and I'm going to represent it with a dotted line. Okay? So that red dotted line here, this is my x component. Okay? So that's the total of all the east I went, all of the horizontal I went. So I'm going to just put in brackets here. This is the total. So even though I went east and west and kind of northeast-ish, this is just all my total of how far east I went. And then we do the same for how far north you went. So the dotted line going up is my y component. Again, this is my total. So, once I've figured out my x component and my y component, I can find, basically as you can see this is a triangle, I can find the hypotenuse. The hypotenuse, if we're working with a triangle in this case, this is known as the resultant or net vector. So, this is the resultant or total x component, this is the resultant or total y component, and this is overall what happened. Okay? So, this is also the shortest distance between the start and the finish, right? Okay? Just like we know of a hypotenuse. Since the resultant is at an angle, the direction of the resultant must also include an angle. So I need to be able to give directions on how far north of east this is, or how far east of north, or I'd say, 36 degrees, etc. So I'm going to show you how to do those different things. But this is our angle that we're talking about. So there's two methods for doing our angles that we will be discussing. You always need to start by drawing your grid lines at the starting point of your vector. So to draw a grid line, that's a 4 grid line. So you have your north east, south, and west as our grid lines here. The blue arrow is my resultant vector. This is what actually happens. And these are all my grid lines. Here is my start, and here is my finish. So, to do the cardinal reference is our north, south, east, west. So again, we draw our grid lines. So this is our first example. Okay, now let's say if we measured this angle is 30, I should put theta. So theta, have you guys seen this in math before? That symbol? So theta just meaning angle. It looks bad because my pen is off, but a circle with a line in the middle. So theta is equal to 36 degrees. So when I do this, I can say, I'm going to start here. So it's the vector direction angle is reference to the nearest axis. So this is near to the east axis. So this is north, 36 degrees north of east. Okay, so of east. So this is 36 degrees north of east. If we were to put this in a summary kind of notation, they would write it as such. So bracket E is what you put first, what it's referenced to is put first in this type of summary, E 36 degree N. So the reference first, 36 degrees, you went north of it.
Which one's the reference?
So the one, like, you just pick. Generally, it's best to pick the closest one. So 36 is closer, like this line is closer to the east quadrant axis line.
So if it was like 60, then you'd say north of east, 60 degrees north.
Right, so I'll do another example. Like, well, and I'll show you the other way to write this too. So say we were to give north be the reference. This is the preferred way to do it closest, but so say each square is 90, so 90 minus 36 degrees is 54, so I know the rest of this is equal to 54 degrees. So if I wanted north to be my reference point, then I would say that this is, so we can say or, this is 54 degrees east of north. So you just got to make sure that whatever you choose as the reference, it needs to be the correct angle. And preferably the axis to choose is the one that's closest, but either could be correct. Yeah?
So what is 45? And does it not matter?
Either one. Yeah. Good question. Okay, and then so in the summary notation, N 54 degrees E. Okay, let's do the next example. So drawing in your grid lines. And the theta here is equal to 15 degrees. So we can say that this is 15 degrees east of south. Okay. we went east of the south axis line, or summary is S 15 degrees E. If you were to use the east quadrant line as your axis, or as your reference, this theta here, we go 90 minus 15 is 75. So you could write this as 75 degrees south of east, or E 75 degrees S. Okay, moving on. Alright, so this is the other method. So using the bearing or navigator's reference. So when we look at our grids, now we're looking at 0 or 360, 90, 180, and 270. Okay, so again, still we draw our grid lines. Okay, so my theta here is 25 degrees. And say though I was looking for this. Because when we're doing our bearing or navigator's reference, this is like our 0. Oh, I shouldn't use red. This is our 0. So we want to see how far away from 0 the line is, or the vector is. So I need to figure out the red theta here, because this is how many degrees it has moved away from north, or away from 0. Okay, so we need to go theta, we'll just call it theta B. Theta B is equal to 90 minus 25 degrees. So theta B is equal to 65 degrees. And that would be your answer, because it's moved 65 degrees north. But you don't have to say east of north or anything like that, because we're just on the grid navigator reference. Okay, so again, here, draw.
You have to give a direction at all, or?
Nope. No directions needed. Okay, so again, drawing your grid. So what I want to find out is that, say you imagine that this arrow started here and it went tick, 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 all the way around. You want to see how far around did this arrow go. That's basically what we're trying to figure out there. So there's a number of ways you could do this. Well, and I'll tell you what this theta is here. So the theta between the arrow and the nearest axis is 30 degrees. So we know this is 90 plus 90 plus 90 plus 30. What is it? 300? Yeah? Yeah. So theta is equal, we'll call this theta B equals question mark. We'll just say, yeah. So theta equal to 300 degrees, because it's gone 300 degrees around. No directions or reference needed. Okay, so this is just a little intro to 2D problems. We'll do more of it tomorrow. But, for example, you drive 3.5 kilometers west before turning and driving 7.8 kilometers north. What is your resultant displacement and what is your total distance? Okay, so let's draw our two vectors. So say I'm going to start here, and I'm going to drive west. So this is my 3.5 kilometers west. Then you went and drove 7.5 kilometers north. And then this is my finish.
Say again, 7.8.
Thank you. Okay, but I'm going to find out what my resultant net is. Oh, and when you're drawing these vectors like this, make a note to yourself, use tip to tail. So you want to put the tip of this north vector to the tail end or the arrow of the west vector. You don't have to, but it's easier when dealing with your vectors. You can still get the correct answer otherwise. But okay, so A, what is my displacement? So, how do I find, this is my displacement. How do I find displacement? What kind of theory could I use to figure out what that line? Pythagorean theorem. Wow. Awesome. So, a squared plus b squared equals c squared. Oh, and I forgot to give you, this is theta is equal to 66 degrees. So you could use your trigonometry too, which we'll do next day. So if you don't want to do trig, you can just do Pythagorean's theorem for now.
Well, trig's easy too.
Yes. We'll just have to remember our cosine, sine.
How do we know it's 66 degrees?
I just tell you. But I tell you in the question. Yeah, sorry.
So in another question you tell us, like you'd have.
Yeah, or, yeah, generally it would be given to you, yeah. Okay. Okay, so now, when I'm writing this in, if I think about this vector, because I need to put my directions on here, so 8.5 kilometers, 66 degrees. Now, it's gone 66 degrees in reference to what? Well, that's when you draw in your grid. So this is north, east, south, west. So it's gone 66 degrees north of west. But, as we know, sometimes it's just a little bit tidier to reference the closest axes. So you could also write this. What is the angle between here and the north then? So 90 minus 66. so this would be 24 degrees. So I could also say that this is 8.5 kilometers, 24 degrees west of north. Either or. Both are correct. Okay, so that was part A. It asks us, part B, what is your total distance? Well, distance is a scalar quantity, so what do? I just add up 3.5 kilometers plus 7.8 kilometers. Because this is not my shortest, it's not the shortest route, this is your distance. How far did you physically travel? Okay, no direction, no nothing. So this is just 11.3 kilometers. No direction needed because it is a scalar quantity.